We have a tough problem today. We will be finding the intersection points of two graphs, two functions. We're drawing graphs. We are figuring out the vertex of polynomials. There is a lot to unpack. Hi, and welcome to Algebra Examples. I'm Dr. Finch. I have a PhD in math and over 20 years of experience in math education. Thank you to the viewers who sent questions in. Today we're looking at a really interesting one sent in. If you have a question that you'd like to be answered, please send it to purplefinchmath@gmail.com. Okay, so here's the wording of our example for the day. The graphs of the two quadratic polynomials f of x is equal to x squared minus 2 and g of x is equal to 2x squared plus 4x plus 1 intersect at 2 points. Draw enough of their graphs to show how they intersect. Ooh, okay, so lots of stuff going on here. One of the things that we can first do is let's start out by finding where they intersect. So we will find where these functions intersect. When we're looking for where two lines or two quadratic formulas intersect, quadratic functions, what we'll do is we'll take those two functions and we'll set them equal to each other. Okay, and now we're going to solve for x. This looks really complicated right now, but let's clean it up and maybe it'll look a little bit better with a few steps. First of all, let's get everything on one side. So let's subtract x squared. What we do to one side, we have to do to the other. So we are left with negative 2 is equal to, and 2x squared minus x squared, we got one copy of x squared left over. Everything else comes down. Let's get that 2 over onto the right-hand side. So we're going to add 2 to both sides. That leaves us with 0 on the left-hand side. And on the right-hand side, we end up with x squared plus 4x plus 3. Okay, so now we have a nice quadratic function. We know how to solve these. We got a lot of different tools in our toolbox. If you want to, you can use the quadratic formula. In this case, I think we're just going to factor it. It might be a little bit quicker. When we are factoring our polynomial, remember we want two numbers that multiply to the number 3. So that's the last number in our formula here. And we want those numbers to add to 4. And that's their middle number. Okay, so I usually start off with the numbers that multiply to 3, and I break it down and I say, what different two numbers can we multiply to get 3? In this case, there's only two numbers that work. That would be 1 and 3. So those ones have to be the ones that we use, and 1 and 3, you can add them up to get 4. In this case, notice also that we have plus signs everywhere. When you have plus signs everywhere, it's the nicest thing ever because we know that we have plus signs in our factorization. We aren't quite done. We factored it, but once we factor it, we know that each factor can be equal to 0. So we have to set both of our factors equal to 0 and solve. Our first solution is x is equal to negative 1, and our second solution is x is equal to negative 3. All right, so we know that the two lines intersect at x is equal to 1 and at x is equal to negative 3. We're going to go to the next page. I'm going to rewrite our functions at the top here. We have 2x squared plus 4x plus 1. We know they intersect at x is equal to -1 and -3. So let's just kind of put a little bit of something down because we know we have to draw this at some point. X, Y. We know that we're going to need at least up to -3, -2, -1 on our x-axis. So somewhere in there is where these things intersect, these lines. Let's look at the first one that we have. F of x is equal to x squared plus 2. Let's see if we can draw this one up. Now, the nice thing about f of x is equal to x squared plus 2, when x is equal to 0, our y value is equal to 2. So, oops, that's a typo there. That should be x squared minus 2. There we go. And we got a -2. So we know we should be at least at -2. Let's put this 1, 2. And this tells us information about how our function should look. So we know we hit this point right here for our, let's put that in purple. We know that it is a quadratic function. Our out in front of the x squared is positive. When we have a positive number in front, we know that we are looking at a happy face. In fact, both of them, you'll notice, are positive. So g of x itself as well is going to have a happy face type look to it. If we draw up our graph, one thing that we could do is we could figure out roughly where it's going to hit us on the x-axis. Our solutions to see where we're going to fall when we cross our x-axis. To do that, let's set our y values equal to 0. Add 2 for both sides. So we're going to solve. And then x is equal to plus or minus the square root of 2. Now, I don't know about you, but I don't memorize exactly where square root of 2 is. It's not worth the brain space. It's also a number that never ends, so not worth it. No way you can actually memorize the whole thing. However, we can figure out where on our graph it roughly is by noting that square root of 2 is less than square root of 4 and bigger than square root of 1. I always like to think about how my numbers relate to other numbers because it gives me a better way of estimating what's going on. So our square root of 2 is between 1 and 2, which means negative square root of 2 is between -1 and -2. So our root, it kind of hits somewhere in here and somewhere in here. We're not going to be exact. We're just going to kind of tuck that in. Okay, it's not a very pretty one, but it will do. So there's our f of x. Now we know, actually, let me make this a little bit bigger. We know that our functions are going to hit at x is equal to -1 and at x is equal to -3. So we know where g of x hits at those two functions. Our next question is, how does g of x look like on this? You know, is g of x going to slope down? Is it going to slope further down and then come back up? What's going to happen there? So let's look at our g of x. And figure that out. Now, if you want to, you can solve for the roots of g of x to figure out where it crosses the x-axis again. That's one of the first things I did, and I looked using the quadratic formula. It is not pretty. It really is not pretty. I'm going to show you what it is anyway. It is -1 plus or minus 1 over the square root of -2. And yeah, I thought that looked ugly. So I thought, let's take another tact at this. Let's figure out, find the vertex of g of x. That might help us draw this graph a little bit better. Remember, when we're talking about a quadratic, the vertex is our h comma k. It's that central place where we have that symmetry for our quadratic function. So our values here, if we're figuring out our h and k, first thing we need to do is figure out what are the coefficients a, b, and c. Our coefficient a is 2, b is 4, and c is 1, and we get them right up from our g of x up here. Next up, we plug those into the formula that we have for h and k to figure out our vertex. So this is going to be h comma k. Our h formula is equal to negative b over 2a. So we're looking at negative 4 over 2 times 2, or negative 4 over 4, negative 1. Our k is f of h, or f of, in this case, negative 1. In this case, this gives us 2 times negative 1 squared times 4 times negative 1 plus 1. I will point out, don't forget the squared there when you're plugging your h value in. Very important and often overlooked because it's very easy to overlook that squared in there. Negative 1 squared is a positive 1. Positive 4 times negative 1 is negative 4. 2 plus 1 is 3. So our k value is negative 1 as well. In this case, our hk is negative 1 comma negative 1. Oh my gosh, look at that. It is exactly right there where we know that our functions hit. And so that is where the symmetry is for our functions. So it's going to go up like this and up like that. And now we see where our functions look, intersect. And there's our lovely little graph, although quite a scary journey. Again, if you enjoyed this, please leave a comment. And if you have a question that's a little bit complicated you'd like to see worked out, please send it to purplefinchmath@gmail.com.